Yes.
Did you say that this Friday is the last day to retake the test?
No, next Friday, May 6th, is the last day to take the test, Chapter 8 test. So the formula for work is equal to force times the distance so how much force multiplied by the distance times the cosine of theta. So that is your formula. Go ahead and read that question. You're looking for 3 numbers. Substitute that in, and you are done. It's pretty simple question when we're trying to find work. Okay, so it says that the force is 18 newtons. The rope pulling the cart forms an angle of 35 degrees with the ground, and we need to determine the amount of work if the boy pulls the cart for 40 meters. So we have our force is 18 multiplied by the distance, which is 40, times the cosine of 35. So type that in your calculators. And you should get 589.789, and that's in joules. Joules is newtons times meters. All right, so we're in the very back of our note packet, and we have 2 more questions to do. So go ahead and go to the very last page, and let's look at question number 5. Yeah, it's posted. So for question number 5, it says a plane is in the air traveling at a speed of 408 miles per hour in still air. The plane's heading is 40 degrees. If the wind is blowing from the west at a speed of 15 miles per hour, find the actual speed of the plane in the air and its heading. All right, so we need to figure out our plane. And we need to add that to the wind, and that's going to tell us the actual speed. So to find our components for the plane, we take the speed times the direction. Now here's the thing though. They told us the heading. So in order to find the direction for the plane, so for our plane, we have to take the heading. We have to take 90 minus the heading to get theta. So the angle that I'm going to use to find our horizontal and vertical component is 90 minus 40. So we're going to use 50 degrees. So when you're trying to find your horizontal and vertical component, you do not use you use the direction. You don't use the heading. That's really important. So for my airplane, theta is going to be 90 minus 40, which is 50. So this is the angle that I'm going to use to find my horizontal and vertical component. So for my airplane, I have 408 times the cosine of 50, and then 408 times the sine of 50. And I'm going to add that to the wind. And it says that the wind is coming from the west. So remember, if you're coming from the west, that means you're going east. So who remembers what angle do we use for east? 0. So if you were absent yesterday, if you're going east, theta is 0. So when going east, theta is 0. And when going west, theta is 180. So if the wind is going towards the east, theta is 0 degrees, and if the wind is going towards the west, it's 180. So it says that the wind is going from the west. So if it's going from the west, that means it is going east. Yes. Okay, so right here, you have to use theta. So they didn't tell us the direction. It said the plane's heading is 40 degrees. Okay, and when you're finding your horizontal and vertical component, you need to use the direction. So it's 90 minus the heading. So we have to take 90 minus 40, and we're using 50 degrees. So when you're finding your horizontal and vertical component, if you go to the bottom of page 8, you use the direction, not the heading. Does that make sense? Okay, so that's why we're using 50 degrees instead of 40 degrees. Okay, so now we're on the wind. So the wind is traveling at a speed of 15 miles per hour from the west, so that means it's going east. So it's going 15 miles per hour towards the east. So we have 15 cosine 0 and 15 sine 0. That's my wind. So this vector is my plane, and then this is my wind. Go ahead, pick up your calculators. So we have 408 cosine of 50, which would be 262.257. And then we have 408 sine of 50, which would be 312.546. And we're going to add that to our wind. So the cosine of 0 is 1. 15 times 1 is 15. And the sine of 0 is 0. And 15 times 0 is 0. So let's find the actual. So the actual speed is the plane plus the wind. So let's go ahead and add these two vectors together. So you're going to add the 262. So you're going to add your horizontal component, and then you're adding your vertical component. And when you add, you should get 277.257 and 312.546. So using this vector, find your magnitude and your direction. So using that, go ahead and find the magnitude. So that's how you find your magnitude. Go ahead and type that in your calculator. So you're taking your horizontal component squared plus your vertical component squared. Take the square root. And you should get that it's going to be approximately 417.8 miles per hour. Who got that for their answer? All right, good. So now let's find we are going to find our heading, but first we need to find the direction. So this question is asking us for the heading. So what we're going to do first is find the direction. So in order to find the direction, we're going to take the inverse tangent of y over x so theta equals the inverse tangent (312.546) all over 277. Oops. Oh, I erased that. I didn't mean to erase that. Here, let me put that back. Okay. So when you type that in your calculator, so you have the inverse tangent of y over x, and you should get that the direction is 44.479. Oops, that is not it. I'm on the wrong question, y'all. I'm so sorry. The direction is 48. My handwriting is so messy. Is that what you all got in your calculator? 48.424? Okay. But it's asking for the heading. Okay? So, and if you look on the board, I gave you the formula for heading. Heading is 90 minus the direction. So, to get full credit when you take your test, if it's asking you for the heading, you have to subtract 90 minus the direction. So the heading, because the heading is with the north and the direction is with the horizontal. So it's 90 minus 48.424, which is 41.576 degrees. So let me highlight our answers. Let me highlight them in pink. So this would be your final answer that I would be looking for on the test. And the speed here. So here and here. Those are your final answers. Does anyone have any questions about how we're working through? So this is the back of homework 19. That's why I pushed the due date from today to next week. So we only have one more question, number 6, and I want you to try to do it by yourself. And then when you get your answer, raise your hand and I'll tell you if I agree. So go ahead and try to do number 6 by yourself, and then we'll go over it together. All right, I'm going to go ahead and work through it. So first we need to write a vector for our plane. So for the airplane, you have 405 cosine 42, 405 sine 42. We're adding that to the wind. And the wind is 25. And again, we're going to use 180. So it's cosine 180 and 25 sine 180. Okay, so that's your first step. Write your vectors. And then we pick up our calculators. Can I borrow that calculator? Thank you. All right, so we take the 405 cosine 42, and we get 300.974. And then 405 sine 42 is 270.998. Add that to the wind. So the cosine of 180 is -1. So that's going to be 25 times -1, which is -25. And the sine of 180 is 0, so that's 0. Add those two together, and you get 275.974 and 270.998. This is our actual, this is the plane plus the wind. So now you're ready to find the magnitude, which is the same as your speed. So the speed is going to be 275.974 squared plus 270.998 squared. And when I type that in my calculator, I got 386.784 miles per hour. All right, so now let's find our direction. So when you're finding your direction, that's the inverse tangent of y over x. So that would be 270.998 all over 275.974, which is going to give you a theta of approximately 44.479, but it's asking you for the heading. So to find your heading, we need to subtract that 90 minus that angle. So heading is going to be 45.521 degrees. And that would be your heading. So use this time to finish out homeworks 19 and 20. On Monday, I will pass out the test review, and Thursday is your test. If you have any questions, feel free to bring up your homework. If there's anyone taking a retake today, please remind me. Other than that, that's it. Have a good weekend.